Hi everyone, in this video we will understand how to check whether there is a path exists between source and destination of a given graph. Let's say there is a graph given and somebody told you, let's say 0, 1, 2, 3, 4, 5, 6. These are the vertices of the graph and somebody told you to check whether there is a path between 0 to 6, right? So by looking at this graph we can see that there is a path. Let's say 0, 1, 2, 3, 4, 5, 6. There is one more path 0, 1, 2, 3, 4 and 6, and there is another path between 0 to 1, 0, 3, 4 and 6. So if somebody told you to check if there is a path exist between the source and the destination, so when you are writing the code for it, you don't need to care about like which path you are following. You just need to check like either the path is existing or not. So so in I will explain you this question. First of all, I will write the code of it, and whatever I will be explaining you will be aligned as per the code. And in the initial time I will write the wrong code, and as we traversing through this given input, we will be improving the code so that you can understand each and every line of that code. So since we have to check if the path exists or not, so whatever the function we are writing, it should have a bool return type, because it will tell it is true, like the path, if the path is there then it say true, otherwise it say no. So the code will be like this: bool function graph, then source node, then destination. There is one more thing that we will understand what is wrong in that code. Now see, let's say if somebody told you that like you need to check the path between 0 to 6, right? I go from 0 to 1. If there is a path between 0 to 1, then it means 1 is neighbor of 0, it means there is a path from 0 to 6. If somebody told you that there is a path between 2 to 6, then it means there is a path we can go from 0 to 6 also. So in our code, what we are doing, we will changing our source node. Initially the source node is 0. As we are making the recursive call again and again, we are just moving forward, and what we are doing, we are just changing the source node. So that's why, so we are changing the source node till what time? Till we are reaching at the destination. So when our source node become equal to the destination node, then we simply say that there is a path exist, and we say return true, right? Now after this, let's say we started from 0, and we are what are the things we can do? Like mostly whenever you are solving the question of a graph, this graph represent the adjacency list. So whenever you are solving a graph problem, you are just traversing the adjacency list. So in adjacency list means like you are traversing the node of it. And so like whenever you need to find the distance or the path, if there is exist a path or not, then we usually prefer DFS. And in DFS there is one thing that we do mostly is doing a recursive call. So to do a recursive call, so we need to find where we need to do a recursive call. So we started from 0, we need to go to the its neighbor, all the neighbors, and then we do a recursive call. So then we will write is like we are just traversing through its all neighbors of the source node. So auto neighbor of what? Neighbor of source node. 0th neighbor are 1 and 3. So the graph will tell you all the neighbors of source node. Now I told you that we have to do the recursive call. So when we are moving forward from 0 to 1, I mean its neighbor, then we make it as a source node. So we will do a recursive call with the same function. But what actually changes? is graph will be the same. Since initially the source node is 0, now the source node become the neighbor, and then rest thing are same. So this is the recursive call. We have done it. Now our code is done. Now we will do a dry run on this given input, and we will check what are the things our code is lacking, and then we will improve our code. So we will do a source node is 0 and we need to go to 6. Now source is not equal to destination, 0 is not equal to 6. So what we do, we will go through its neighbor. So 0th neighbor are 1 and 3. Now we will do a recursive call. We entered into this. Now we need to do a recursive call having neighbor as a source node. So 1 become the source node and we need to go to the 6, right? So we came here. Now we will check 1 is not equal to 6, so this will not run. Then we came to this point, so we need to check the neighbor of 1. So 1's neighbor are 0 and 2. So 0 and 2, right? So you are observing one thing, that as we are moving forward, our destination become, or like our task is becoming smaller and smaller as we are moving forward. So see, like from 0 we came to 1. Now if we came to 0 again, then our path is expanding again, but we don't want it, because if we start from here again, then the same thing will do, I mean the same thing we have to do it again. But as we are moving forward, we don't want it to go to the same thing. So there is a chance of improvement in this code. Why? since we are since it is a undirected edge, so zeros neighbor are 1 and one neighbor is also a 0. So whenever we are moving from 0 to 1, and we don't want it to go it back again, so what we do, like when we are moving forward from 0 to 1, we make 0 as visited node, so that we don't need to do the same thing again when we are dealing with the same node. So we have to maintain a visited vector that initially set as, like all the entries in that visited vector will be set as false, and as we are moving forward from source to node, we will make it as true. Why true? Because we don't want it to go to the same node again. So since we again do the dry run, so we are at 0, its neighbor are 1 and 3, we came at 1. Now 1's neighbor are 0 and 2, but 1 is, whenever we marked 1, we marked 0 as true, so now it is true. Now we check its neighbor. 1's neighbor is 0, but 0 is already visited, so we don't need to go in this path. Now we came to the second neighbor of 1, that is 2. 2 is not marked, I mean, for your sake I will make it like this: 0 1 2 3 4 5 6. Initially all are set as false. Now in the first go we marked it as true. Now we check at its second neighbor. 2 is marked as false, and yeah, now since it is marked as true, so we will do a recursive call. There is one thing we need to improve, that is, we can mark this, we will go into this only when visited of neighbor false. We will only doing the recursive call when there is a case that visited, like the neighbor is false. Since one's neighbor is 2 and the neighbor is false, so that's why we will do a recursive call making 2 as a source node. Now we came again at this point. 2, we need to go to 6. 2 is not equal to 6, so this will not run. Now we marked 2 as true, so 2 as true. Now what are the neighbor of 2? 1 and 3, right? Since we already came from 1 to 2, so 1 is already visited, we will mark it as true. Now we will not go to the 1 because it is marked as true. We will only checking on, we are only making a recursive call when it is false. Now 3, we came at 3, right? 3's neighbors are 0, 2 and 4. Since 0 is already true, so this will not go further. 2 is already true, this will also not go. 4 is false, so we will do a recursive call from this point. Now we need to go from 4 to 6. This is also 3 to 6. 4 is not equal to 6, so this will not run. Now we marked 4 as true, right? Now we will do, we will go into 4's neighbors. So 4 neighbor are 3, 5, 6, right? 3 is already true, so we will not do anything. Now 5 is false. 5 is false. 5 is false, so we will do a recursive call making 5 as a source node. So we need to go from 5 to 6. Since 5 and 6 are not equal, so we will mark 5 as true. Now we will go from 5, we will go its neighbor, 5's neighbor. So 5's neighbors are 4 and 6, right? 6 is already true, so we will not go into this. Now 6 is false, right? 6 is false. Now since 6 is false, so we will do a recursive call making 6 as a source node. Since 6 source and destination are equal, so we will return true from it. So we will return from this point. Now since we came at 5, now 5, so all the neighbors are done. All the neighbors are done, so we will again backtrack from 5 to 4, right? 5's 3 is done because it is true. 5 is from, since we came at 4 and 4 has 3 neighbors, 2 are already done. Now the third, since we got our destination, right? So do you think we need to go to 6? No. Why? Because we just need to check if there is a path exist between source and node. We already found that 0 and 6 is there. So do you think we need to we need to check its third neighbor if we already found the path? Then there is one more thing we will add in this, is we will store this in bool answer. So this answer become true. If the answer is true, then we will return true from this point. Now we came at 4, 3 is done, 5 is done. Now we need to check with 6. But before that, like, we are done with this. Now this line will run, but this line says true. So true means it will not check for 6, it will return from 4 point only. So we will return from this. Now 3 is never done, then this done, then this done, and then this done. So in the end, what we need to do is return true. So these are the things that we improved in our code. So this is the final code. So what we have added, this thing, then this thing, these two things, and then the third thing. So this is our final code. We can go this point also, but what is the point? We need to check if the path is exist. We don't need to care about what path we are following, right? So this is how we can find if the path is exist or not. So this is the part 1. In the second part, I will tell you what are the possible paths, right? So we will improve in this code only. Like, initially we have done this thing, right? And we, like, in this code we did not traverse in 6, we did not traverse in 3. So like, to find all possible paths, we will traverse in each and everything, but there is just a little change in that code, and you will get to know about all the possible paths. So that's all for the video. Thank you.